Dear students, welcome to the video past examination paper solving mathematics 9709 statistics 1 AS level paper 6-2 October-November 2018. Question number 1, part I. How many different arrangements are there of the 11 letters in the word Mississippi? Okay. Now, as you see here, there are 11 letters, of which you have 4 S's. So, 4 factorial. I is also repeated 4 times, divided by 4 factorial. P is repeated twice, so divide by 2 factorial, which gives you an answer of 34,650. For the second part, 2 letters are chosen at random from the 11 letters in the word Mississippi. Find the probability that these 2 letters are the same. So when they are the same, it means that they are either both S or they are both P, or they can both be I. So how many S's do we have? It is 4 out of 11. Okay, if the first one is S, so the probability of S, you will have 1 less S, so it will be 3 out of 10 because you have 10 letters to choose from. Now for P, if the first one is P, so you have 2 P's, so 2 out of 11. If the first one is P, the second one will have the probability of 1 out of 10 then. Plus for I, you have 4 I's, so 4 out of 11 times, if the first letter is I, so you will, in the next trial you will have less I, so it will be 3 over 10, which overall will be 12 over 110 plus 2 over 110 plus again 12 over 110, which will give an answer of 26 over 110, which simplifies to 13 over 55. Question number 2. The following back-to-back Zeeman leaf diagram shows the reaction times in seconds in an experiment involving 2 groups of people, A and B. And you see here information concerning A and here group B. And the keys given that 5 line 22 and 22 line 6 are actually read as 0.225 for A, and here for B will be 0.226. Part I, find the median and interquartile for group A. Now, for the first part, as you see here, there are 4 plus 5 and 9 plus 8, 17 plus 6, 23 plus 3, 26. There are 27 actually items here for group A. Now it is odd number, so for odd number Q2 will be actually n plus 1, which is 27 plus 1 over 2 data. So which is 27 plus 1, 28. It will be 14 data will be median. So Q2 will be equal to, now 14, so 4 plus 5, 9. And you have here 9, so it will be 10, 11, 12, 13, and 14, which will be read 0.225. It is the median, 0.225. And you are supposed to also find interquartile range, so we need to find Q1. Q1 will be, before the median, here it was 14 data, so before the median you have 13 actually data. So for 13 data, 13 plus 1 divided by 2 which will be 7th data. 1, 2, 3, 4, 5, 6, 7. So it will be 0.215. Likewise, Q3 again will be 7th data, but in the second half. 1, 2, 3, 4, 5, 6, 7, which is 0.2, 1, 2, 3, 4, 5, 6, 7, 0.236. 0.236. Now, interquartile range is the difference between Q3 and Q1, which will give you an answer of 0.021 for the first part. Now, for the second part. For the second part, it says the median value for group B is 0.235 seconds, the lower quartile is 0.217 seconds, and the upper quartile is 0.245. Draw the box and whisker plot for A and B on the grid. Now, in order to construct a box and whisker plot, you need to have these items: minimum, actually lower quartile, median, upper quartile, and maximum. For A, as you see here, it would be 0.2 is the median, 0.205 is is the minimum for B, is the minimum for A. Here A, here B. Q1 or lower quartile is 0.215. For group B is 0.217 as given. For Q2, for group A, we found 0.225, 0.23, 0.235, and Q3 we found here 0.236. Q3 for the other group is 0.245. Maximum data is the last data. For group A is 0.250, and for group B is 0.258. Now I first need to construct a number line actually. Now after constructing the number line, we scale them. I move at the step of 5. So here will be your minimum data, here will be your maximum data. Here it is Q1, Q2, Q3. Here is minimum data, here is Q1, here is maximum, Q2, Q3. As you see, for example, here minimum data is 0.205, set A, set B. It is corresponding to 0.205. Minimum is 0.2, so 0.2. Then Q1, Q2, Q3, and maximum. Question number 3. Jake attempts the crossword puzzle in his daily newspaper every day. The probability that he will complete the puzzle on any given day is 0.75, independently of all other days. Part I, find the probability that he will complete the puzzle at least 3 times over a period of 5 days. Now, as you see, let X be the random variable, the number of days he completes the puzzle. It has actually binomial distribution with 5 as the number of trials, and the probability of completing, which is your success, is 0.75. Now it says at least 3 days. At least 3 days means 3 or more, which is equal to probability of X is equal to 3, or X is equal to 4, or X is equal to 5. Now here you can also find the probability of x is equal to 0, 1 and 2, then subtract from 1. Probability of x is equal to 3 will be a combination of 5, 0, 0.75 to the power of 3. Sorry, it was 3. Let me fix it. It is 3. Then your q will be 0.25. 0.25 to the power of 2, because 3 success, so definitely 2 failures. Plus combination of 5, 4, 0.75 to the power of 4, 0.25 to the power of 1, because out of 5 trials, 4 are success, so 1 should be failure, and combination of 5, 5, 0.75 to the power of 5, 0.25 to the power of 0, which will be 0.896. Now for the second part, it says Kenny also attempts the puzzle every day. The probability that he will complete the puzzle on a Monday is 0.8. The probability that he will complete it on a Tuesday is 0.9 if he completed it on the previous day, and 0.6 if he didn't complete it on the previous day. Find the probability that Kenny will complete the puzzle on at least one of the 2 days, Monday and Tuesday, in a randomly chosen week. Now I use 3 diagram here. Now there are 2 possibilities for Monday. Monday here, it will be complete or not complete with probability of 0.8. Not complete will be 0.2. Then for Tuesday, again 2 possibilities: complete, not complete, complete, not complete. If he completes on Monday, so probability for Tuesday will be 0.9 completing and 0.1 for not completing. Likewise here. Now it says at least one of the 2 days. At least one of the 2 days means 1 or more. So here in the first branch you see complete, so it satisfies the condition 0.9, because at least 1 means 1 or more. Here he has completed in 2 days. Then here at least 1 day is completed, Monday is completed. However, Tuesday is not complete, Monday is completed, so at least 1 is the case here. So 0.8 times 0.1, and the last one here, this branch, not complete on Monday but complete on Tuesday, which is 0.2 times 0. Here sorry, it was 6, and so it would be 0.4. Then 0.2 times 0.6 here, because not complete on Tuesday, so final answer will be 0.92. Question number 4, first part, find the number of different ways that 5 boys and 6 girls can stand in a row if all the boys stand together and all the girls stand together. Now we have 5 boys. I put them like in a box, and there are 6 girls. 6 girls. I put them in a one package, second package. So because boys are to be together, girls as well to be together. So here we have 2 boxes. In how many ways these 2 boxes can permute? So it will be 2 factorial times. Now go inside the box. Boys can have 5 factorial permutation, and inside this box get 6 factorial. So it will be 172,800 for the first part. Now, as the second part, find the number of different ways that 5 boys and 6 girls can stand in a row if no boy stands next to another boy. Now, so first I arrange girls here. They are more. G1, girl 2, girl 3, girl 4, girl 5, and girl 6. Now, so in 6 factorial ways, they can have permutation. But now we have 5 boys. Boys are to be placed in these actually locations. Now, for the first boy has 1, 2, 3, 4, 5, 6, and 7 options to stand. So for the first boy 1, boy 2, boy 3, boy 4, and boy 5. Now, second boy, so actually one of them will be occupied. The second boy will have 1, 2, 3, 4, 5, 6 options. Then another one will be occupied. Then next one will have 5. Then next 4. Then 3. If you multiply them, it will give you 1,814,400. Question number 5. The Quiver Archery Club has 12 junior members and 20 senior members. For the junior members, the mean age is 15.5 years and the standard deviation of the age is 1.2 years. The ages of the senior members are summarized by sigma y is equal to 910 and sigma y squared is equal to 40,850, where y is the age of a senior member in years. Now part I, find the mean age of all 32 members of the first part, find the mean age of all 32 members of the club. Now, here we know that for the seniors, the sum of ages is 910, but we know that mean is actually sum of data divided by number of data. For juniors, mean is 15.5 and sum is unknown, and 12 is the number of data. So sigma x is 100 and actually 12 times 15.5, which is 186. Now the total mean for all 32 members will be 910 as the sum of the seniors plus 186 as the sum of juniors over the total members, which is overall 32 members, which will be equal to 34.25. Part 2, it says find the standard deviation of the ages of all 32 members of the club. So first we go for the variance. We know that variance of x is sigma x squared over n minus x bar s squared. For juniors, we have 1.2 s squared, as you see, is equal to, we need sigma x squared over n, which is 12, minus 15.5 s squared as their mean. So sigma x squared will be 2,900.28. Now, in total, variance actually will be, let z be the total, all seniors and juniors together, will be sigma actually x squared plus sigma y squared over n, which will be 32, minus Now z bar squared. Z bar is the total mean that we obtained in the previous part. Now, so it will be equal to sigma x squared. For juniors, we obtained it was 2900.28 plus sigma y squared. For seniors is given for the 2850 over 32 minus the total mean s squared, which is 34.25 s squared, which is equal to 256.63. But a standard deviation is root of variance, so standard deviation will be radical 256.63, which is 16.02. Question number 6. A fair red spinner has 4 sides. Number 1, 2, 3, 4. A fair blue spinner has 3 sides. Numbered 1, 2, and 3. When a spinner is spun, the score is the number on the side on which it lands. The spinners are spun at the same time. The random variable x denotes the score on the red spinner minus the score on the blue spinner. Draw up the probability distribution table for x. Now, sample space is including the first spinner 1, the second 1, so 1, 1. It will be 1, 2, 1, 3, then 2, 1, 2, 2, 2, 3, then 3, 1, 3, 2, 3, 3, 4, 1, 4, 2, and 4, 3. These are possibilities. Now, for the probability distribution table, now here x and probability of x is equal to x. Now, what are possible cases? 1, 1, 1 minus 1 will be 0, 1 minus 2 negative 1, 1 minus 3 is negative 2, so negative 2 is the lowest one, negative 1, 0 if they are equal. We have difference of 1 for 3, 2, 2, 1, difference of 2 also, and maximum difference will be 3. Now, here, difference of negative 2. There are just 12 cases, difference of negative 2. It means that here just gives you the difference of negative 2. So 1 and 3, probability of 1 is 1 over 4, probability of 3 in the second one will be 1 over 3, 1 over 4 times 1 over 3 is 1 over 12. Or you can say that there are 12 cases. Just one case gives you the difference of first one minus the second one, negative 2. So it is 1 over 12. Negative 1. For negative 1, we have this one, so 2. That's it. So 2 over 12, difference of 0. First one minus second one is 0. Here, one case, 2 cases, 3 cases. So it will be 3 over 12. Difference of 1 will be 1, 2, and 3. So it will be 3 over 12. Difference of 2. Here, nothing left. 1, 2. So it will be 2 over 12. Difference of 3. There's just one case, which is 4 and 1, which is 1 over 12. Now for the second part, which is variance of x. We know that formula of variance of x is equal to sigma x squared p of x minus mu or e of x squared. First I find e of x. E of x is equal to sigma x p of x, which is minus 2 times 1 over 12 plus minus 1 times 2 over 12 plus 0 times 3 over 12 plus 1 times again 3 over 12 plus 2 times 2 over 12 and 3 times 1 over 12, which will be equal to 1 over 2. Now I replace in this formula, then variance of x will be sigma x squared, so it will be minus 2 squared times 1 over 12 plus minus 1 squared times 2 over 12 plus 0 squared times 3 over 12 plus 1 squared times again 3 over 12 plus 2 squared times 2 over 12 and last one 3 squared times 1 over 12 minus e of x, so 1 over 2 squared, which will be equal to 23 over 12 at the end. Part 3, find the probability that x is equal to 1 given that x is non-zero. So third part, probability of x is equal to 1 given that x is a non-zero number. So it is conditional probability, will be probability of x is equal to 1 and x is non-zero number over probability of x is a non-zero number, which will be equal to, now here x is equal to 1 and non-zero, so the intersection of these two, the common part will be x is equal to 1. So because x is equal to 1 satisfies both conditions, it's equal to 1 and it's non-zero, so probability of x is equal to 1 is 3 over 12. Probability of x is not 0, x not 0, so will be these cases 1 over 12 and 2 over 12, and all these together will be 9 over 12, so it will be 3 over 9, which simplifies to 1 over 3. Question number 7, part A, the time x hours for which students use a games machine in any given day has a normal distribution with mean 3.24 hours and a standard deviation 0.96 hours. On how many days of the year 365 days would you expect a randomly chosen student to use a games machine for less than 4 hours? So x has normal distribution with mean 3.24 and standard deviation is 0.96, so variance will be 0.96 squared. So it says use a games machine for less than 4 hours. So we first find probability of using games machine less than 4 hours. First we need to standardize x minus mu, which is 3.24 over 0.96 less than 4 minus 3.24 over 0.96 standard deviation. So probability of z less than 0.7917 will be equal to 0.7858. It is the probability of using a game machine for 1 day. So it says for a year 365. So it should be multiplied by 365, which is almost equal to 286 days. Now second part, it says find the probability of case such that probability of x greater than k is 0.2. Again we standardize first minus mu, which is 3.24 3.24 divided by 0.96 minus 3.24 over 0.96. Now I label here z, probability of z greater than k minus 3.24 over 0.96 will be equal to 0.2. Now here I first construct normal distribution curve. Now probability of z greater than a fixed number is 0.2. It is 0 in a standard and normal distribution. On the right hand side, area is half, so the area of this fixed point is 0.2. So the point is somewhere here. So this is the region. So when it is 0.2, so the region before of phi of this number here is k minus 3.24 over 0.96. So phi of this number is 0.8. Now phi of k minus 3.24 over 0.96 is equal to 0.8. Now find the number corresponding to 0.8 in the table, which will be k minus 3.24 over 0.96 is equal to 0.842 from the table. Then if you do cross multiplication, k will be 0.96 times 0.842, then it's transferred to the other side, plus 3.24, which is equal to 4. Actually k is equal to 4.05 as k. Now part 3, it says find the probability that the number of hours for which a randomly chosen student uses a games machine in a day is within 1.5 standard deviation of the mean. Now actually we want probability of x. It says within 1.5 standard deviation of the mean. So the difference from the mean should be 1.5 standard deviation from both sides. 1.5 standard deviation. Now we need to standardize. In order to standardize, mu is already subtracted, so we just need to divide by sigma, which is a standard deviation to standardize. So it will be z here. So probability of z greater than sigma and sigma cancel out each other. So negative 1.5 and less than, here there is no 1.5 less than positive 1.5, which is equal to phi of upper bound minus phi of lower bound. Again is equal to phi of 1.5 minus phi of negative number will be 1 minus phi of corresponding positive number is equal to 2 phi of 1.5 minus 1. From the table, 2 times phi of 1.5 is 0.9332 minus 1, which gives you an answer of 0.866. Part B, the variable y is normally distributed with mean mu and standard deviation sigma, where for sigma is equal to 3 mu, or you could say mu is equal to 3 over 4 mu. Now, and the mu is a non-zero number. Find the probability that a randomly chosen variable y is positive. So we are looking for probability of y greater than 0. First step is to actually standardize y minus mu over sigma greater than 0 minus mu over sigma. Probability of z greater than 0 minus mu over sigma is 3 over 4 mu. Now it will be probability of z greater than 0 minus mu. If you simplify, it will be minus mu. Mu cancel out. It will be negative 4 over 3. Now from the normal distribution curve, let me show you here that exactly what happens and what region actually we need. Now here negative 4/3 is a negative number, here is 0. Negative 4/3 is, for example, somewhere here. We are looking for the region after, is here. And the table doesn't give us the region after a number and also information concerning negative numbers. So we make it positive, it will be 4/3. This region in terms of area, in this region is equivalent to the region before this 4/3, which is 5, actually 4/3. So it will be 5 positive 4/3, which will be equal to, from the table, 0.909.